Hey, this is Patrick Sullivan. Welcome to my shop. A few years ago, I bought a so-called trim router, and I made a small tabletop stand to support it. Gradually, I added some modifications until I had something that really worked. This has become the most successful single accessory in my shop, and it's taken over the large majority of my routing tasks. I thought I would build a new one to show you the process. I put together a complete set of plans which are available on my website at no cost. First, although this small router table could be easily adapted for any of the 10 or more trim routers on the market today, it is designed specifically for the DeWalt 611. I recommend this router for several reasons. First, it is extremely versatile with both a fixed base and a plunge base. The motor is 1.25 horsepower, so it's powerful enough for a wide range of mid-sized jobs, and yet it is compact enough that it can be used one-handed. But a big part of its success in this situation is that its controls are all easily accessible and visible from the front of the table. At its heart, this table is simply a plywood box with a cutout in the top. I started by cutting out 3 rectangles out of 3/4 inch or 18 millimeter plywood. The right side is simple. You just need to open up the center. I did this with my scroll saw, but a saber saw or a coping saw would work well. The back has rabbets on the 2 short sides, sized to match the thickness of the plywood. These rabbets make the assembly quick and painless. Once again, we cut out a large hole in the back for access and light. The left side is more complicated. Remove this odd-shaped piece to allow the dust collection channel access to the vacuum. Next, cut away the rectangular piece at the front edge. And finally, cut out a large opening in the center, just as with the other 2 sides. The left leg also houses the wrench. I traced the profile of the wrench onto a scrap of 3/16 inch plywood and used this cutout to locate holes for 2 rare earth magnets which are epoxied in place. It is much easier to drill and mount these magnets now before the table is assembled. A hole near the top of the wrench provides extra clearance for your finger when extracting this tool. My original table was plywood, but I wanted something flatter with more dimensional stability. Many router tabletops are made from melamine particle board. However, MDF is flatter, smoother, and supports very accurate cuts, so it was my first choice. However, the only MDF with melamine on only one surface that I could find was 1/4 inch or 6 millimeter product. I laminated this 1/4 inch thick MDF to a piece of conventional 3/4 inch thick MDF. I used epoxy to bond the 2 sheets to avoid any distortion caused by absorbing water from conventional wood glue. I don't know if this was necessary or not. I got a very flat, uniform result just using conventional bar clamps. I then cut a slot in the 2 short sides to hold a strip of aluminum that will form the guide rails for the fence. These slots must be cut quite accurately. Take your time. Cut a channel in the top to fit a piece of T-track. It's 3/4 inch wide and 3/8 inch deep. I cleaned out the channel and adjusted the depth with a shoulder plane. Mark and cut the irregular shape along the front edge. The dimensions are in the plans. This edge will be visible, so strive for straight, smooth cuts and clean up any saw marks with sandpaper. Now mix epoxy and glue in a strip of aluminum cut to the exact length of the sides, in both sides. The aluminum is 1/8 inch thick and 3/4 inch wide. If it fits into the saw curve snugly, then it needs only a small amount of epoxy to hold it securely in place. The best and easiest way to route a recess for the router base is to make a template to guide the router. Start with a sheet of 1/4 inch or 6 millimeter MDF. Cut it to the exact size of the tabletop. Mark out a rectangle the size and location of the recess. Cut this shape out using a saber saw, a coping saw, or a scroll saw. MDF cuts so rapidly that you can easily do this by hand. Smooth the cut edges with a sanding block right down to the layout lines. Secure the template to the tabletop with light-duty double-sided tape. And try to keep the template square and even with the tabletop. Screw a guide bearing into the factory base. I used a 1/4 inch spiral bit, but any small bit that fits the guide bearing will work. Make the first cut very shallow to ensure clean edges on the melamine. Then deepen the recess in several steps. We will build a new polycarbonate base for the router, and obviously this recess must match the thickness of that polycarbonate exactly. Incidentally, keep this template for a while after you finish. In the event that you want to deepen the recess a tiny amount, you can easily remount the template and adjust the depth. Next, cut out the shapes for the low-profile dust collection channel out of 3/4 inch MDF. There are full-size templates on my website. At the left side, where the port for the hose adapter fits on, the channel tapers slightly to fit into the round shape of the adapter. Cut away the MDF to provide a smooth airflow with minimal obstruction. You can do this with a rasp or sandpaper, but I found that a large gouge cut very cleanly and rapidly with no dust. You can refine the shape of these curves by setting them in place and looking through the opening in the left side leg. Glue the curved shapes for the dust collection to the underside of the table. These parts form part of the support for the left leg, and they need to fit tightly where they join to the left leg and the vacuum hose adapter. Set the left leg in place and dry fit these parts to locate them precisely. Once the glue is set, cut out a sheet of very thin plywood to form the bottom of the air channel. The plywood I used was 3/16 inch or a little less than 5 millimeters, but it could be even thinner. Glue the left side or leg to the tabletop and glue it tightly to the dust collection channel. Then put glue in the rabbets in the back piece and glue it to the left side. Finish up with the right side. Clamp the sides to the back. Then adjust the position of the leg assembly on the top. I strengthen the glue joint between the top and the sides by inserting glue blocks, as you can see. Press the top onto the sides and back with weights. I made a pair of stepped blocks that serve the dual purpose of holding the router bits and securing the sides to the base. Glue 3 pieces of wood together and clamp them. Saw them to length and drill holes slightly larger than 1/4 inch to a depth of about 1 inch. The spacing depends on the number and size of bits you want to store. The base is a piece of 3/16 inch plywood. I glued the table to it and then reinforced the 2 sides by gluing in the bit storage blocks. The ends of these blocks also glue to the back, making a very rigid structure. The 2 blocks will hold a total of 50 bits between them. This may not encompass your entire collection of bits, but it will ensure that the bits you use most commonly will always be immediately at your fingertips. The vacuum hose port is made from 1-inch thick stock, and I supply a full-size template for it in my plans. The hole in it must accurately fit the male end of your vacuum hose, and these vary in size. If you have a drill bit or a hole saw that works, then use it. But cut a test hole to be sure it fits. I did not have a bit that worked, so I cut my port on my scroll saw. While I was at it, I put in a 1-degree taper, although this is not strictly necessary. You could glue this port in place, but I wanted to be able to replace it if I bought a new shop vac, so I just screwed the port on. Next, I installed a piece of T-track. This is an aluminum extrusion that's available from many suppliers. It's held in place with 4 screws. Here's the mini table, complete except for the router and the fences. It's compact and lightweight. You can see how handy the bit and wrench storage is. The new base for the router is made from 3/8 inch or 9mm polycarbonate. Simply saw out a rectangle that exactly fits the recess you routed on a table saw using any blade. Then round the corners slightly to fit the recess with sandpaper or a file. The easiest and most accurate way to drill the mounting holes in the right place is to use the factory base as a template. Make centering marks and attach it with double-sided tape. Find a bit that matches the hole size closely and drill a shallow dimple in the new blank. This will provide an accurate center for a Forstner bit to drill recesses for the screw heads. Then change to the smaller bit and drill the holes for the shank of the mounting screws. These holes are slightly oversized to permit the base to be precisely centered later on. In order to drill a hole for the router bits, chuck in a pointed bit or a very tiny bit and attach the base to the router. Then turn on the router and raise the bit slowly until it makes contact with the plastic base. This will leave a perfect centering mark. I then removed the base and drilled a 1 1/4 or 30mm hole. This will accommodate a fairly large chamfer or roundover bit. Clean up the drill holes as needed with a countersink or a blade, and you're ready to drop the router into its place. The little fence on this table is really quick and easy to use. It can be made from scraps. Start by cutting 2 strips of wood about 1 inch or 25mm square. Saw a kerf in them to fit the aluminum guides in the tabletop. Then cut 2 strips of 1/2 inch or 12mm plywood. Cut a channel in 1 strip that will comfortably hold a 1/4 inch or 5 to 6mm threaded rod. Glue the 2 pieces of plywood together. Cut a block of wood about 1.5 inches square or 38mm and drill a hole in it to fit the threaded rod. Create a recess a little smaller than a nut and enlarge the hole to capture the hexagonal corners of the nut. This does not have to fit perfectly because we will epoxy it in place. Dry fit the pieces of the fence and mark the cutout where the block will go. Cut this shape out of the plywood piece and cut a matching notch in the left runner. Be certain that the notch in the plywood sits slightly behind the edge of the table as shown. The block must press against this edge of the table to clamp the fence. Glue the 2 runners to the plywood crosspiece while they are in place on the top so you can ensure that the fence fits snugly onto the table but still slides smoothly and easily. Turn the threaded rod into the captured nut in the block and then insert the rod into the fence. Turn the cam lever onto the rod and adjust until the fence clamps tightly. As you can see, the fence should be rock solid when it's clamped. I put a sacrificial face on the front of the fence so that a bit can be partially buried. I just cut a strip of 1/2 inch or 12 millimeter MDF and attached it with double-sided tape. You can easily remove this if it becomes worn. It's extremely easy to make a cross-cut fence. Just cut a strip of wood to fit into the T-track and glue a second piece of wood to it at 90 degrees. The guide strip does not need to match the complicated profile of the T-track. It just needs to fit between the two lips at the top of the track. Okay, that's it. This little table will do hundreds of tasks, and it takes up very little space. You can move it easily to wherever you have a place for it. If you need to use the router alone, you can remove it in seconds. The dust collection is pretty good. In some cases, it may pick up over 90% of the chips. If you want to build this, you can download the plans at my website. The link is in the description below. If you like this video, consider clicking the like button and perhaps subscribing to my channel. Just click my picture in the right corner. Thanks for watching.